Rockets are vehicles designed to travel beyond Earth's atmosphere by utilizing controlled explosions to propel themselves into space, and the process of making them involves several meticulous steps, including the design phase where engineers create blueprints that detail every part of the rocket's structure and systems, followed by the selection of materials based on their durability and weight, which are then manufactured into large components like the rocket body and engines, before moving on to the assembly stage, where all parts are fitted together, integrated with complex systems for navigation and communication, and finally undergoing rigorous testing to ensure they can withstand the extreme conditions of launch and space travel. Once all components are assembled, the rocket undergoes a series of critical tests that include static fire tests to evaluate engine performance and ensure that all systems function properly under high stress. And these evaluations are vital because they simulate conditions that the rocket will face during launch, leading to adjustments and improvements if necessary before the final pre-launch checklist is completed, which includes thorough inspections for safety, proper fueling procedures, and ensuring that all onboard systems are ready for liftoff, culminating in the rocket being transported to the launch site where it stands against the horizon, poised for its exhilarating journey into outer space. When the countdown reaches 0, the rocket ignites its engines, producing an immense force that propels it upward through the atmosphere. And this spectacular moment is not only a testament to years of engineering and planning, but also marks the culmination of all the hard work put in by hundreds of dedicated individuals who ensured every detail was perfect. As the rocket ascends higher, it passes through various layers of the atmosphere, each presenting unique challenges such as varying air pressure and temperature, which the rocket's structure and systems are designed to handle, ultimately breaking free from Earth's gravitational pull and venturing into the vastness of space, where it can then embark on its mission, whether that be deploying satellites, carrying astronauts to the International Space Station, or exploring distant planets. A ballistic missile is a projectile weapon that follows a suborbital flight path and is powered during its initial phase. Once it has reached a predetermined altitude, it coasts toward its target due to gravity and aerodynamic drag, making it distinct from other types of missiles. The missile is launched from a fixed or mobile platform where it ignites its rocket engines to propel itself into the sky during the boost phase, reaching speeds that can exceed several thousand kilometers per hour. After the boost phase, the missile enters its mid-course phase where it coasts in space outside the atmosphere, traveling along a predetermined trajectory before re-entering during the terminal phase where it accelerates toward its target for impact. Upon reaching its target, the warhead detaches from the missile and descends at high speed, often utilizing guidance systems to ensure greater accuracy, leading to devastating consequences upon impact, thus highlighting the importance of effective missile defense strategies. The proliferation of ballistic missiles poses significant strategic challenges for nations worldwide, necessitating the development of advanced detection and interception technologies to counter such threats effectively, thereby influencing global military dynamics. To safeguard against potential attacks from ballistic missiles, countries invest heavily in missile defense systems that integrate cutting-edge technologies including radar detection, interceptor missiles, and automated decision-making systems to enhance their response capabilities. The ability to detect and intercept ballistic missiles during their flight remains a contested field, leading to ongoing advancements in both offensive and defensive technologies, thereby shaping future military strategies and international relations. The development of ballistic missile technology has evolved significantly since its inception, transitioning from rudimentary designs to sophisticated systems capable of delivering payloads over vast distances, which has transformed warfare and international security paradigms. Sound is a vibrational phenomenon that travels through various mediums such as air, water, and solids in the form of waves, where it starts with a source that generates vibrations, leading to the compression and rarefaction of air molecules, which then creates pressure waves that our ears perceive as sound. These waves are classified mainly as longitudinal waves, where the particle movement is parallel to the direction of the wave propagation, in contrast to transverse waves, and as they move through different materials, Sound travels at varying speeds. For example, it travels faster in water than in air. The essential characteristics of sound waves include amplitude, which determines the loudness of the sound, and frequency, which dictates the pitch, with higher frequencies perceived as higher pitches and lower frequencies as lower pitches, all of which are intricately processed by the ear's anatomy, particularly within the cochlea. As sound waves travel away from their source, they diminish in intensity due to various factors such as distance and environmental conditions, creating what is known as sound decay, which illustrates how our perception of sound changes based on proximity to the sound-emitting object. Furthermore, sound is quantified in terms of decibels, a logarithmic unit that measures the intensity of sound, enabling us to compare different sounds ranging from the faintest whisper to the roar of a jet engine, which the brain then interprets to understand various auditory experiences. Additionally, our environment is filled with diverse sources of sound, each producing unique sound waves. These sources can be classified into categories like musical sounds, speech, and environmental noises, while techniques and materials for sound insulation are employed in architecture to control sound levels and enhance auditory comfort. Moreover, the Doppler effect is an intriguing phenomenon where the observed frequency of sound changes based on the relative motion between the sound source and the observer, leading to unique auditory experiences, such as the change in pitch of a passing siren, while other effects like echoes and resonance further showcase the fascinating behaviors of sound in different settings. Artificial intelligence, or AI, is a branch of computer science focused on creating systems that can perform tasks typically requiring human intelligence, such as recognizing speech, making decisions, and translating languages, through intricate processes that involve machine learning, where algorithms analyze and learn from data patterns to improve their performance over time. The process begins with collecting vast amounts of data, which are then used to train the AI models through various methods such as supervised learning, where labeled data teaches the model to make predictions, or unsupervised learning, which allows the model to find hidden patterns without pre-existing labels. Once the data is gathered, it is fed into a neural network, a structure inspired by the human brain, where the information passes through various layers of interconnected nodes, each layer extracting features and ultimately leading to an output that makes predictions or classifications based on the training it has received. As the model is trained, it undergoes validation and testing to ensure its accuracy, where metrics such as precision and recall are evaluated, allowing researchers to make necessary adjustments before deploying the AI into real-world applications, which often requires iterative improvements based on feedback and new data. Once validated, AI systems can be integrated into various applications, transforming industries such as healthcare, where they assist in diagnosing diseases, finance for algorithmic trading, and even autonomous vehicles that navigate complex environments, showcasing the versatile capabilities of artificial intelligence in enhancing our daily lives. However, as AI continues to evolve and become more integrated into society, it raises important ethical questions regarding bias in algorithms, the potential for job displacement, and the need for accountability in decision-making processes, prompting ongoing discussions among technologists, policymakers, and the public to ensure responsible development and deployment. Water, a vital substance for all known forms of life, is a transparent, tasteless, odorless, and nearly colorless chemical compound that consists of two hydrogen atoms covalently bonded to one oxygen atom, forming the essential molecules that make up about 60% of the human body and cover approximately 71% of the Earth's surface. The water cycle, also known as the hydrological cycle, is a continuous process where water evaporates from the Earth's surface into the atmosphere, condenses to form clouds, and eventually returns to the surface as precipitation in the form of rain or snow, thereby replenishing water sources such as rivers, lakes, and oceans. Water plays a crucial role in various human activities such as recreation and agriculture, as it provides not only a source of enjoyment and relaxation at lakes and rivers, but also serves as a fundamental resource for farming, enabling the growth of crops and sustaining food production systems that feed billions of people worldwide. The quality of water is of utmost importance for public health, as scientists rigorously test water samples to ensure they are free from harmful contaminants, while in everyday life, individuals in cities rely heavily on safe and accessible water sources such as public fountains and bottled water to stay hydrated and maintain their health. As the demand for fresh water increases due to population growth and climate change, innovative solutions such as desalination plants are being developed to convert seawater into potable water, while individuals and families are also adopting sustainable water practices like collecting rainwater to conserve this vital resource and reduce their ecological footprint. Despite covering about 71% of our planet, the distribution of water is uneven, with only approximately 2.5% classified as fresh water, most of which is trapped in glaciers and ice caps, thereby highlighting the critical importance of conservation efforts undertaken by communities and scientists alike to protect and restore aquatic ecosystems for future generations. A nuclear weapon is a device that releases energy through nuclear reactions, primarily through fission or fusion, where atoms are split apart or combined under extreme conditions, leading to an explosive release of energy that is millions of times more powerful than conventional explosives. The fundamental principle behind a nuclear weapon involves initiating a chain reaction where a heavy nucleus, such as uranium-235 or plutonium-239, absorbs a neutron, becomes unstable, and then splits into smaller nuclei, releasing additional neutrons and a significant amount of energy. To create a functional nuclear weapon, sophisticated engineering is required to ensure that the fissile material is properly assembled into a supercritical mass, which is necessary for the rapid release of energy during the explosive reaction, and this assembly can be triggered using conventional explosives in what is known as an implosion design. When the weapon is detonated, the rapid release of energy creates an intense fireball and shockwave, leading to devastating effects, including extreme heat, radiation, and widespread destruction that can obliterate entire cities within seconds and leave long-lasting environmental impacts. The use of nuclear weapons is not only a technical challenge but also a moral and ethical dilemma, as their devastating consequences have led to international treaties and efforts aimed at nuclear disarmament, aiming to prevent future conflicts and protect humanity from the catastrophic impact of nuclear war. Throughout history, the development and proliferation of nuclear weapons have sparked intense debates over security, deterrence strategies, and the risks of accidental launches or terrorist access, prompting nations to engage in complex negotiations to balance national security interests with global safety. As society continues to grapple with the existence of nuclear weapons, education plays a crucial role in raising awareness about their risks, promoting peace initiatives, and encouraging future generations to pursue disarmament and innovative solutions for a safer world. Muscles are soft tissues composed of cells that have the unique ability to contract and relax, enabling movement, generating force, and maintaining posture through a complex interplay of biochemical processes and interactions between proteins, specifically actin and myosin, which operate via the sliding filament theory to facilitate muscle contractions. Muscle contraction begins when a nerve impulse stimulates muscle fibers, triggering the release of calcium ions that bind to regulatory proteins, thereby exposing binding sites on actin filaments for myosin heads to attach, allowing the subsequent power stroke that pulls the filaments past each other and creates tension. To fuel these contractions, muscles rely on adenosine triphosphate, ATP, as the primary energy source, which is generated through various metabolic pathways including aerobic respiration and anaerobic glycolysis, allowing for sustained activity and the ability to perform tasks ranging from simple movements to intense physical exertion. Muscles are composed of different types of fibers, primarily slow-twitch and fast-twitch fibers, each serving distinct functions in endurance and strength activities, and following exercise, they undergo a recovery process where micro-tears in the muscle fibers heal, leading to muscle hypertrophy and improved strength. Proper nutrition plays a critical role in muscle health and performance, as proteins provide the essential amino acids necessary for repairing and building muscle tissue, making it important for individuals to consume adequate amounts of protein along with carbohydrates and fats to support energy levels and overall muscle function. Additionally, muscles work in coordination with the skeletal system where they are attached to bones by tendons, enabling smooth and efficient movement across joints, and thus proper warm-up and stretching routines are essential to prepare the muscles for activity and prevent injuries. Chewing gum is a soft, cohesive substance designed to be chewed without being swallowed, made primarily from a gum base combined with various sweeteners, flavorings, and softeners, leading to an intricate manufacturing process that begins with the preparation of the gum base, followed by blending it with additional ingredients, heating and kneading the mixture, cooling it down, extruding it into desired shapes, and finally packaging it for distribution. The process of making chewing gum involves several critical steps that ensure the final product is both enjoyable and safe for consumers, starting from the selection of high-quality ingredients, where sugars and flavorings are meticulously measured and mixed, followed by rigorous quality control checks to maintain consistency and flavor integrity, and concluding with an exciting array of finished products emerging from the production line, ready to entice customers with their vibrant packaging and delectable taste. Once the gum mixture is thoroughly processed and shaped into desired forms, it undergoes cooling and cutting, where it is transformed into individual pieces that retain their fresh flavors, followed by packaging that captures the eye and preserves the product's quality, ultimately leading to the delightful experience of consumers who enjoy chewing gum as a fun pastime or a refreshing treat during social activities. At this final stage of the chewing gum production process, once the packaging is complete, the finished products are carefully boxed and prepared for distribution to stores worldwide, ensuring that consumers can easily access their favorite brands, while also highlighting the role of chewing gum in promoting social bonding and enjoyment among friends and peers, as people often gather to share flavors and create memorable experiences together. The diverse array of chewing gum products available in stores reflects not only the innovation that goes into product development, but also how these flavors and brands cater to different consumer preferences, with many individuals enjoying chewing gum for its refreshing taste and even its potential benefits, like improved concentration during tasks, making it a staple in many people's daily routines. Trees are complex living organisms that play a crucial role in our ecosystem, starting from a tiny seed that germinates when conditions are favorable, growing into a sapling that gradually develops roots, stems, and leaves, which enable it to absorb sunlight, water, and nutrients from the soil. As the sapling matures, it undergoes photosynthesis, converting sunlight into energy while releasing oxygen, and with time, it develops a sturdy trunk that supports its height, completing its transformation into a tree capable of supporting animal life and contributing to its environment. Trees consist of several essential parts, including roots that anchor them into the ground and absorb water and minerals, a trunk that provides structure and support, branches that extend outward to maximize sunlight capture, and leaves that play a pivotal role in photosynthesis. Throughout their life cycle, trees not only provide habitats for countless organisms, but also enhance soil quality through their root systems that prevent erosion, enrich the earth with organic matter, and promote biodiversity by creating microhabitats for various species. As seasons change, trees adapt beautifully, showcasing different characteristics with each cycle, from the brilliant colors of autumn foliage that attract attention to their stark nakedness in winter, reminding us of the natural rhythms of life. The act of planting trees has profound implications for our future, as it fosters not only environmental sustainability by improving air quality and combating climate change, but also strengthens community bonds through collaborative efforts that educate and inspire individuals to take action. Trees are vital components of ecosystems, offering shelter and sustenance to a plethora of wildlife, thus maintaining ecological balance while also enriching our surroundings with their beauty and providing essential resources like timber and fruit. Through their incredible ability to sequester carbon, trees serve as natural climate regulators by helping to mitigate the effects of greenhouse gases, playing an indispensable role in our fight against climate change and ensuring a healthier planet for all living beings. Plastic is a synthetic material made from polymers that are derived from petroleum and natural gas, and the manufacturing process begins with extracting crude oil or natural gas, which is then refined to produce ethylene and propylene, key building blocks for plastics, followed by polymerization, where these monomers are chemically bonded together to form large chains known as polymers, which can then be processed into various forms including sheets, films, and molded products. After polymerization, the plastic is further processed through methods such as extrusion, where it is melted and forced through a die to create specific shapes, or injection molding, where melted plastic is injected into molds to form complex shapes, followed by cooling and solidifying, which gives the plastic its final form. And finally, these products undergo a quality check to ensure they meet safety and performance standards before they are packaged and sent out for use. In addition to new production, plastic recycling plays a crucial role in managing waste and reducing environmental impact, where used plastics are collected, sorted by type, cleaned, and then processed through methods such as shredding and remelting to create recycled pellets, which can be reintroduced into the manufacturing process to produce new plastic items, thus creating a circular economy and minimizing reliance on virgin materials while addressing global plastic pollution challenges. To address the growing concerns over plastic waste, researchers are developing biodegradable plastics made from natural materials such as corn starch or sugarcane, which undergo chemical processes that allow them to break down more easily in the environment. And by comparing these innovative materials to traditional plastics, we can visualize significant differences in their degradation rates, providing potential solutions to reduce the environmental footprint of plastic products while promoting sustainability. Chocolate is a delicious treat that begins its journey as the seeds of the cacao tree, which are extracted from ripe cacao pods, fermented to develop their flavor, dried under the sun, roasted to enhance their taste, and then ground into a fine chocolate liquor before being mixed with ingredients like sugar and milk to create the final delectable product. After the grinding process, the chocolate liquor is tempered, which involves heating and cooling the chocolate to stabilize it for a smooth texture, and then it is molded into various shapes or blended with additional ingredients like nuts, caramel, or fruits to create the wide array of chocolate products that we enjoy today. Finally, the finished chocolate is cooled and packaged for distribution, ensuring that this delightful treat reaches stores and shops where chocolate lovers can indulge in its rich flavors and various forms, from solid bars to exquisite truffles. In the end, the experience of chocolate goes beyond just taste. It involves the joy of selection, the excitement of sampling, and the artistry of chocolatiers who transform simple ingredients into captivating works of art that bring happiness to people all around the world. Chocolate not only serves as a delightful confectionery, but also plays a significant role in various celebrations and traditions, where it is often gifted or shared among loved ones, creating sweet memories and adding to the joy of special occasions. Whether it is handcrafted in small batches by passionate chocolatiers or mass-produced for everyday enjoyment, chocolate's versatility allows it to be an essential ingredient in desserts, a delightful gift, or a luxurious treat that continues to enchant and satisfy palates across generations. The journey of chocolate begins long before it reaches our hands, deeply rooted in the hard work of farmers who cultivate cacao beans on plantations, and it ends with creative culinary uses that transform everyday ingredients into lavish desserts, reminding us of the rich history and craft behind this beloved treat. Rubber is a natural polymer obtained from the sap of rubber trees, primarily Hevea brasiliensis, and the process of making rubber begins with tapping these trees to collect the milky white latex, which is then transported to processing facilities, where it undergoes coagulation using acids, followed by washing and drying to remove impurities, before being transformed into various forms through methods like vulcanization, where sulfur is added to enhance durability and elasticity. After coagulation, the latex transforms into solid rubber, which is then filtered and shaped into sheets or blocks that are spread out to dry under the sun or in drying ovens, ensuring they lose excess moisture while retaining their essential properties before being processed further into products such as tires, gloves, and various industrial goods. Once the rubber sheets are fully dried, they undergo further processing where they are mixed with various additives such as carbon black for added strength and antioxidants to prevent degradation. Then this mixture is thoroughly blended in large industrial mixers before being shaped and cured in molds through heating, which solidifies their final form, ensuring each product meets strict quality standards. Following the curing process, engineers often utilize computer-aided design software to create precise models of the rubber products that are intended for production, allowing for optimization of performance and efficiency. Once these products are finalized, they are packaged and stored in warehouses, ready to be distributed to various markets around the world, signaling the culmination of a meticulous manufacturing journey from tree sap to essential everyday items. In order to ensure high standards are maintained, quality control laboratories rigorously test the rubber samples for properties such as durability, flexibility, and resistance to wear and tear, using specialized equipment that simulates real-world conditions. These final rubber products, now proven for their reliability, find their way into numerous applications. From the tires that support vehicles on roads to the soles of shoes that provide comfort, highlighting the vital role rubber plays in our daily lives. A rocket launcher is a portable device designed to fire rockets or missiles, typically for military or space exploration purposes. It operates by propelling a rocket using controlled explosive forces to achieve flight following specific scientific principles. First, the launcher holds a rocket with a combustible propellant inside its chamber, ready for ignition. When the trigger is pulled, a fuse ignites the propellant, creating rapidly expanding gases that generate high pressure. This pressure forces the rocket's engine to ignite, producing thrust based on Newton's third law. For every action, there is an equal and opposite reaction. The rocket's engines burn fuel, which releases hot gases through a nozzle at the rear, propelling it forward in accordance with the laws of physics. Guidance systems embedded within the rocket help steer it toward its target by adjusting fins or using onboard electronics. Once the rocket reaches its designated altitude and velocity, it can detonate or deliver payloads depending on its mission. Understanding these scientific principles allows engineers to design more efficient and accurate rocket launchers to explore space or defend nations,